Hello, guys. Welcome to our event. Please put some reaction in chat in order I understand that you can hear and see me well. So I hope you should, but in case of any troubles, yep. So guys, okay. I can see some reaction, some hands, high five. Yeah, so I can consider it as that you can hear and see me well. So welcome again to our event. Today we will have some interesting topic and interesting speaker. We will talk about the composable architecture and yeah, please don't be confused with first letter K, not C, because we will be talking about the composable architecture in context of Kotlin and Android development. That's why, yeah, it's not iOS one. And please welcome our speaker, Sergey Kamenkovich. Hi, Sergey.
Hello everyone.
How are you doing? Sergey joined us from Kiev, Ukraine.
Hello. Yeah, I'm really happy to join and finally have an opportunity to share information about the composable architecture for Android, which is pretty much rare thing in Android community. Many iOS developers already knew about it, used it already in production and like that, but cases for production on Android are really rare, as far as I know.
Let's hope that our talk will be like start for new for new era yeah of the
Hopefully, yeah.
composable architecture for Android. Okay, let me add the slides. Yeah, can you see the slides? Okay,
I can.
and yeah, Sergey, the stage is yours.
Okay, great, thanks. So let's start. Uh, so my name is Serhiy Kamenkovich, as Vladimir said, and today we'll discuss with you what is composable architecture and how it can be used on Android. A little bit about myself. I started a career path as an electronic engineer, programming microcontrollers with assembler. And about 12 years ago, I have switched to mobile development. And besides of Android, I had an opportunity to code for Pada OS with C++ and for a while to do mobile cross-platform with the Flutter and Dart. And for over 3 last years, I've been working on production with the architecture we will be discussing today. So what our presentation will cover? First of all, I will share a bit of a history, how it all started, why it was chosen. And then we will take a look on the architecture and its main components. After that, we will dive deeper into more specific cases and some implementation details which we came up with. And finally, I'll try to share some impressions of using it and make a summary. So let's go. So how it all started, there was a business request, as usual, to start a new project. The team already had quite enough experience in this area and realized that adopting old approaches would not be the optimal choice. Um, Android project approach had shared some ideas of Jack Wharton's state management with Rich Java and Timber's state machine. So team was familiar with unidirectional flow approach. But IS didn't have anything like that. And also one of the main objective was to be able to share the application logic between platforms, make it as close as possible to make development and cross-platform code review easier. After conducting research for some time, even made the proof of concept with Kotlin multi-platform. Unfortunately, not yet stable at that moment, and IS had to use Objective-C as a middleware, as far as I know. And team decided, as a result, to settle on the one option, TCA. At that time, it was growing in popularity, and everyone was fond of it. Android team also liked the concept, but still there were some concerns. The main one, as you may guess, they couldn't use Swift library. Fortunately, we had one of the most extraordinary engineers I have personally met, who was so much inspired by the TCA approach that ported the library to Kotlin in just 4 weeks. And here is again the answer to all who found the mistake in the presentation name. As every Kotlin library that respects itself, it is named with K, and here's the author of the library. So that's how the composable architecture was born. It was written fully on Kotlin. It's public currently on GitHub. You can find it by the link. Eric Java was mainly chosen as it was a perfect fit for the character of the project. Kotlin coroutines and flow just became stable, wasn't so rich in the API, and team didn't have much experience with it yet. Of course, things changed since then, and now we are thinking of supporting coroutines and flow. Anyway, that's a full feature architecture library, which allows to test and debug its components. It contains all necessary tooling inside it. Let's now take a look on how it works. Here you can see the general structure of the TCA and its original authors from Point 3 company. It's Brandon Williams on the left and Steven Sellis. For those who are not familiar with their work, use the link. It contains a series of podcasts on TCA topic where these two nice guys explains everything from why to how they did and how it should be used. Let's look closer on the structure. Here we have actions as control event messages, environment as a provider of all outer dependencies like repositories or other platform-specific entities, state as the only presentation of the app in a particular moment of time, and reducer, which is the heart of the architecture with all the business logic inside. All these parts live within the entity called store, which is the root component of the architecture. And it allows user to interact with it using actions, as you can see here. All actions are consumed by the reducers, which modify the state and or post effects to the system. Effect can be considered as a postponed action producer. In other words, uh, in other words, those are actions which we expect to receive as a result of some events. For example, such event can be a result of network call, failure success, or WebSocket messages, push notification, basically whatever we expect our app to act on. In practice, effects are often created by reducers with the use of environment entity. Moving forward, let's examine how core parts look like in Kotlin and check how it differs from Swift code for registration. So upstate is a simple data class, as you can see, which consists of all parameters of the state. It is not necessarily direct data presented on UI, but UI state can be extracted out of it. Usage of data class and not just class with variables here is important. App action can be a sealed class or interface, which implementations are all actions that should be handled by reducers. Of course, it can be uh, any object or class or whatever, but in that, like without the sealed, but in that case, it might be problematic to handle all the actions inside the reducers to know which actions we should handle. So that's why sealed here is an option. And app environment, it provides necessary dependencies. In this particular example, there are schedulers and a function producing effect. Effect itself is an RX Java observable, just type alias. Of course, it might be not a function, it might be a repository, which is like a container producing some other effects, and then they can be handled by the reducer inside it, like with the use of environment. Let's compare it to Swift. So it looks very similar. That's how it's readable by both platform engineers. So data class is simply converted to or presented on IIS as a structure, which is quotable, and it's marked with observable state annotation. They can simply observe the changes inside the state with it, but we need a data class to be able to check the change inside to compare two states and check what exactly changed. So that's why data class is important. For app action, it's even more straightforward. So it's just an enum, and these cases are just a direct mapping between the platforms. And for app environment, again, it's a structure which contains pretty much the same entities, just presented by other things. So in case of effect, it's just an async functions which provides some data. Here it's int, but string, it doesn't matter actually. So let's move on. Talking about reducer, reducer is presented by a function. The main purpose of this function is to reduce received action by converting it to reduced object, which is simply a combination of a new state and effect. This reduced object is created by this plus operator function. So like it's just a combination of a new state and a produced effect, which are like both optional in this case. So if you are not interested in changing state, just return the state plus none. None is just an observable empty under the hood. For a new state, you can simply create a new one or modify using the copy function, which come in hand here with from data class. And in case you need to produce effect with a single action, you can use just instead of none. Just is an alias for observable just option, just to provide one new action which we want to see. Also, library supports other types of events. For example, if you need to provide many actions by handling one action, and like this merge operator, and there are some other things like fire and forget, future, or something like that for more specific things. And there is an important cancel function, cancel effect, which is supposed to be used when you have a permanent subscription and you want to cancel it when you no longer need it. You might need it because whenever you return an effect um, from the reducer, our store subscribes on it. So the only way to reference and to unsubscribe from it is to use cancel. It is used together with the cancelable extension, which is applicable to all effects. You just pass some ID of some identifier of this kind of events. It can be reused by many effects, and then you can simply cancel it with a single effect action. And finally, all the components are glued together in the store. It contains initial state, reference to the root reducer function, and environment object. This can be created in on-creative application class or with the help of your favorite DI framework upon application initialization. On this slide, you can see an example of view and how we can use our store. So here is just a fragment, and let's check the most important roles. First of all, we need to subscribe to state changes, and it only can be done through the view function. The view function produces the view store out of store, because store actually is a container for previously named thing, and it doesn't allow to access the states. So for that purpose, we need a view store. It makes sure that we receive only distinct emissions of our new state, and also can provide the current state at any moment. Of course, we need to keep our disposables to manage the lifecycle, and do not forget to dispose view store internal subscription to current state when view store is no longer needed. This can be done with the dispose function in onDestroy view fragment, or for example in onCleared method of view model. Also, view store allows to deliver new actions to the store, like when we click buttons. So we can use store and send, or we can use view store and send. Pretty much, it's just delegate in this case. And so that's pretty much all about the main components. On the next slides, we will delve deeper into more real-world cases. First of all, let's look at substates. Architecture is called composable because it allows to compose states one within another and handle them in the same composable manner. What we can see here, our up state now contains an optional setting state, which corresponds to the state of settings screen, which user can open, for example, from menu. And just for example, settings screen might have sub-state like licenses. It's for another sub-screen which we can visit. They're both optional. So it means that until user clicks a menu option, this state will be null. As soon as user makes this action, it is reduced by our reducer, and setting state is created. Same is for opening licenses here from setting screen. Now, if we have a subscription on states, particularly on setting state, we will receive an event of new distinct state appearance, like we had in our view example. Transition from null to something. This event is also called on enter or unwrap in the terminology of the library. But as you can see, settings reducer have different types than our up reducer. So how can some action on setting screen, like open licenses, affect our up state? As you remember, we have the only app state instance within the app and app reducer that is currently connected to our store. Here we come to the very powerful tool, which is called pullback. Pullback allows us to transform the substate actions and states into parent ones and vice versa. Let's look closer on it. So pullback itself is a special form of reducer function which automatically maps states, actions, and environment between parent or global in this case and local components. So global is our app thing, and local is the setting thing in this case. Thus, when local store receives an action, it is first handled by local reducer, and then global reducer gets called with the result of state lens and action prism functions. In this case, it is set, so the new state is modified by this function for global, and the reverse get provides us a corresponding up action to be consumed by up reducer. Same works in opposite direction. If you need to run logic inside settings reducer from global reducer, you can send corresponding pullback action, and it will be transformed using action prism get, and together with local state retrieved from state lens to be passed into settings reducer. Since our setting state is an optional property, we need to start our pullback with optional transformer function, which makes sure that no action will be received by settings reducer if corresponding setting state is null. If it's not nullable, of course, we don't need it. We can just use the pullback. So we declared our substate, its reducer, and pullback. Let's now implement the view for settings. Does it look okay? Yes, but only it would work if a setting state was declared as non-optional. In our case, we need to specify its state as optional explicitly. How can we provide such store out of our app store? So they all should be composed, so glued together. For that purpose, library uses the concept of scopes. From the first glance, it looks very similar to the pullback, but there is an important difference. If pullback is purposed for gluing reducers, scope is used to provide a store in a local narrowed context. For that reason, scope has only one direction of mapper functions. For example, here you can see that we have only two local state and from local action. There are some different implementations where from local action is not needed. For example, if you are not interested in handling the events outside. So if local state can be null, like in our case, our setting state can be null, we use optional scope. Otherwise, we can use scopes function for that purpose to retrieve the store. One of the interesting aspects of the TCA is that app state has to be tied to what user sees on the screen. We came up with an idea of coordinators. It's a UI-less fragment added to nav controller when feature state appears and removed when it becomes null. A flat is a special function again declared in the library. It's a port of Swift if-left operator working as a subscription to optional store, like here. Whenever state is transitioned from null to something, unwrap method is called. And when from something to null, it calls or else. So in that case, we either navigate to settings screen or navigate up, navigate back from it when it becomes null. Inside it, we subscribe to all substates in an order of increasing the depth of its presence in the state. I mean, inside the coordinator. So um, you see its setting state, and then the depth increased. We subscribe to licenses. If we do it in the opposite direction, it will mean that if we decide to navigate to licenses and we don't have the settings, we will create setting state and immediately create a licenses state. And since this subscription goes first, it will call the unwrap first, but our nav graph might not support it yet. So we are still on up screen, on main screen, and we cannot go to licenses. So for that purpose, we need to keep this depth rule and put it only after it. And it also gives us the opportunity to leave all the screens together with the same logic. So if you, for example, from license screen, you need to leave also setting screen, you can simply now the setting state, and it is enough to call navigate up for both of them and simply appear on the main screen. That's about navigation. Another thing that we faced applying TKA is that lots of singleton components and places they are used requires quite a complex dependency injection system. In our project, we use almost every possible Tiger API available for providing and injecting TKA and Android components. So we mentioned coordinators, which should receive the stores. We managed seeing the fragments, stores and scopes. And if we use the view models additionally, we also need to inject our view model factories and view models from there. So like it's pretty much extensive here. Now we checked out library components and nuances of implementation. Let's make some summary. What are the pros of using TCA and Android? Each component is very clean in the structure and has specific responsibility and quite small. So it's really easy to understand it from the first look, understand what it does, and it's really easy to maintain this. Second one is whole app state management. Since all stores shares the same root, it is relatively easy to communicate between components and features and independently react on events without any additional subscriptions across the app. So it's like a event bus system out of the box. You don't need to subscribe too much on anything additionally. Next one is most of the business logic can be tested simply by checking the state of corresponding app or feature after some action. Library is bundled with necessary API for that. It allows to check both simple action and larger flows with unit tests. So you can simply call the send some action, check for how it modified the state, then receive an action if it produced the effect, and again checked for modification of the state, and like that. So on your test store, test looks like that. And of course, since you can use as a test store not just a partial screen reducer, you can use some more generic one, and it allows really to test the flow completely with all the actions and state changes that are happening there. This is an interesting one. It's a common language, so both platform can talk in the same language, it helps a lot to discuss solutions and ideas, and also affects some other points that I will mention. A clear set of breakdown task types. Since components are clear and it's easy to make a breakdown of features into same parts like network, navigation, UI, store, and then wiring task for gluing this all together. And because it's very well defined tasks, everyone understands what needs to be done, so estimations also become clearer here. And everyone on code review, on the developer can simply understand what needs to be done in scope of each task. Development in turn, it is another benefit of common language. For example, some feature can be implemented on Android, another one by iOS developer, and then they can simply swap and practically copy paste the logic and finish much faster. Out of our experience, we get almost 1.5 times boost in the velocity. So it is really a nice option to have. And if you used two previous approaches, in case of some issue in the logic, it can be solved once, because since another platform just copied the flow, it can be resolved by one developer and then just passed to another platform to fix it very quickly. And of course, cross-platform code review becomes a lot easier. Like another developer from, for example, from Android, who is out of context, is probably not the best choice to check the logic. But seems we have this common language teammate from another platform who is in context, can perfectly understand what's going on and provide the necessary comments and checks on your code review request. So, of course, there are some negative aspects because of the large zoo of architectures in Android, and more common one like MVVM dictated by the Google and or clean architecture used widely. Like finding the candidate with experience in TCA or at least any other Redux-like architecture is not trivial. And onboarding can take like a month or more just to understand how it all works together. Here it is comparable with onboarding to Dagger, for example, or some reactive framework when person didn't have any experience with something like that. Navigation, as you've seen, might be also problematic. Coordinator approach is not so clean and requires additional handling and care. And also it produces the boilerplate, and actually that's a general contra for the library, because like pullbacks, scopes, DI here are main contributors, and you need to write a lot of boilerplate code for support this. And upstate restoration is an interesting point here. Since all upstate is in memory, we rarely need to use save at state, but if process was killed by the system, we almost have no option to restore it because we had everything in memory. We cannot restore it. For example, our saved state returns us some information, but we have to drop it because we already cannot restore what we had in our states. So it is possible, but it really requires a lot of efforts to handle it. The next one is troublesome maintenance. Like since one action can be handled in different places, different reducers, and take different forms. So, for example, sometimes you might want to convert one action into some different action, providing some extra information. Um, it might be again problematic to find the issue. It might remind you how we were finding uh, who react on some event bus action. If you don't have proper actions, just the pure classes, you might be really in trouble with finding it. But fortunately, we have a debug option, which can be added to any reducer and print all actions and state changes that happened. And in many cases, it helps to resolve such issues. Upstate in the memory. The bigger possible backstack on the screen and data size, the more memory is consumed by the app, and app performance might get affected. For that reason, states should never contain large media data like images or something like that, only references to it, and amount of dynamic, often changing data should be minimized. For example, if you have data constantly coming to your app, for example, by some WebSockets, it's better to keep in the state the observable state and subscribe on it directly in your view models or fragments, instead of pushing these new state updates every time to the state, because like a lot of things are changing one by another inside the store. So it's better to take care of it. And initial loading, like you've seen, many things needs to be initialized on upload, so it should be done also carefully, because like you need to instantiate your store. It will bring all the reducer tree to load in case it's not something optional. So this all will be injected. It's all will be provided, like environments and like that. So yeah, it should be done with care. And summing up, who in what cases it will work the best, like best suit for interactive apps. If your app displays a lot of data and it is dynamically updated, or if user interacts a lot and wants to see the changes like in different parts of the application on the screen, um, having subscriptions out of the box is very helpful in this case. Upside down seniority pyramid in team. This is because of the complexity of the architecture. It's better to have more senior developers who can establish and maintain architecture in a working state. Business flow testing, as it was mentioned, TCA allows to unit test whole flows without much effort. Screenshot testing we found very convenient, since state represents what we see on the screen. It's very simple to add screenshot tests into your pipeline. You can simply add like a simple test which will capture some particular state. So you only need to compose your state and it will work. It will best suit for rarely changing requirements and for environment, because reworking the flow will require a lot of changes in all TCA components, and as such in tests and the rest parts of the app. Because of that, it suits for well-established business domains who won't come like in 2 days after development of the of some big feature which you were working for months or more, and like every day change the whole flow. It will simply not work here. Um, Next one is a single root apps. So it's the easiest case. It doesn't mean that you can't have many roots, but since you have single root store and reducer and like that, it might be problematic to have several entry points, especially if they can interconnect at some places. Uh, like yeah, it is possible, but like it will require more effort to support it. And out of these points, there are a few cases that you might not want to even look at TCA. For example, in startups, it's a corresponding thing to changing requirements. The changes of requirements are too dynamic here, so it's not the best choice. Another one is when you have a cyclic navigation. So, for example, if you imagine some retail store app where you have some one category, then you go down to some subcategory, then you open the product. From it, you can go to another category where this product is located, and to its parent category and like that. And if you have a requirement to navigate back or again visit the product and then navigate back, this is practically not possible with TCA, because you will need to keep all the states and all the reducers composed one into another, and it will be really problematic to create this tree of stores for this case. So that's also not the best choice if you have such requirement. And also intensive deep link usage. So if you have a requirement that the user should be able to navigate deep inside your app with some URLs, it might be also not the best choice, because you will need to handle all the outer states to be created properly, uh, just to navigate to this inner thing. So it might be problematic here, but that's possible also. So that's pretty much all. I was able to find two different ports of TCA to Kotlin. Both use Core as the base, but both seem to be in alpha or preview and have smaller API and less number of helper tools like TKA. And also, if you're interested in more mature MVI libraries, here are some quite known, like Orbit MVI, for example, or MVI Kotlin. It's very similar, at least in the approach itself, like reducers, states, some actions, effects, and like that. Very similar thing. So that's it.
Okay, okay. Thank you, Sergey. It was really interesting and inspired talk. I believe many people get a lot of new insights about TK. And actually, we have the TCA Creator here in on our stream. Nasos Lucas. Sorry if my pronunciation is wrong. Hello, it's nice that we meet you here. Yeah, Nasos even reacted to us. Yeah, hi again. It's
Hi.
like great to see you. Yeah, about questions. Actually, you answered so many things which guys raised in chats. But one of the thing was from Volodymyr Chernenky about Rix Java. Yeah, so you said that library use Rix Java currently, and
Yes.
as I understand, correct me if I'm wrong, that you guys maybe have some plan for the future to use coroutines or
Uh, yeah, there is an idea of moving to coroutines now when it's quite mature, and there is a lot of community who knows it, and already people inside the team already knows it. So we even started including it into our current applications with TCA, TKA. Maybe at some moment in time, who knows, in future we will migrate. Like it's not already done plan, but you can find it even on the GitHub, like thing to work on.
yeah, I think it could be a great addition. Okay, what else? Actually, I have like couple question from my side as well. Yeah, even I was a bit busy with the chat, but I tried to listen you as well. Yeah, so question about debugging. How do you debug the application? I mean, because again, if compare with things like Redux, for instance, yeah, obviously Redux it's like a big monster. He has some toolkit for debugging and so on. So yeah, a lot of things. I mean, around Redux has been built. But what about here? How do you debug? Are you printing state somewhere in the log, or maybe some other approach?
Yeah, so practically to any reducer, you can simply add like it's a function, right? And over it you can add just dot debug function call, and it will like amend the reducer with posting the result of each reduce action, and you will see the state and action that caused it on each step. So if you think that, for example, in some of this reducer there might be some error, or there is some, I don't know, concurrency of events which you didn't expect, you can simply add this debug and to these reducers, and it will print you all the changes which happened. Of course, it's not so sophisticated like, for example, on iOS it is done, because they are able to just check some particular part of the state which changed and print it. But in our case, we print the whole state, which is related to this reducer, but it also helpful. At least it helped to find some issues already.
Uh, yeah, let's be honest. If you have such great architecture, you don't need debug anything because you don't have any bug. I hope.
Yeah, you usually yes, but sometimes if it's growing to something bigger and you have a lot of included one into another reducer, sometimes you might not understand how it even works how when you need to include your own code, or how to fix it. For example, like when it's extensively posting the effects, and you might not understand who producing them, for example. And this debug easily can help you to find it. So
Mhm.
yeah.
Okay, clear. Yeah, there was another question about onboarding. So how hard is to onboard people on the project? But you mentioned it, yeah. So it's pretty hard. Maybe you can elaborate about how many times in average needs for
Yeah, so
developers.
it really depends on the person who joins
Oh,
the team. So it depends on the previous experience. So if someone had experience, for example, with Redux and Flutter, it's easier. If someone worked with something like that on another project, like I don't know, some UDF or Orbit MVI, I don't know, it's also very easy to jump in. But in case user sorry, user, in case the person, the new member,
He is a user at this case. Yeah.
yeah, he came and he might not understand like pretty much anything, and he really needs to hear a presentation like that one, or and read the documentation and try it out, and only after that, and it might take like couple of weeks to understand. Only after that he will be able to write something in the existing code, and of course he will need to spend some time to understand how it is done in the existing code. So like real case example, we have people who were on onboarding like for a month or 2 months, like it depends. And of course the more senior person, then it is easier, but still it requires some time.
Oh, we have some quick comments from Nasus. but
Yeah,
but
of
I
course.
think it's some of your internal things. Yeah. Okay. Yeah. Anyway, at any case, I think that development, mobile development, more or less is moving in that direction of UDF architectures, right? Which is TKA is obviously also is
One
right.
of them.
One of so if you I noticed that in the official Google documentation, if you will try to find something MVVM or MVP, it will be really hard. They use only UDF, yeah. So we all definitely is moving in this direction. Yeah, it's actually cool example. Yeah, that you guys like following architecture from iOS. Uh, it's interesting. Do we have like opposite case? Yeah, when some iOS team follow it, I don't know, maybe some MVI architecture, it would be also
I
quite
always
cool.
had an impression that iOS get the MVVM from Android.
Yeah,
Uh,
yeah, yeah, actually. And
so
yeah, and I think it's the main benefits for you, yes, that you can read each other code, yeah, because you use the
yeah,
same language,
that's a
the
huge,
same concept, and
huge
you can.
benefit.
So you are like a 50% iOS developer already, no?
Yeah, kind of.
Okay, okay, great. Seems we can wrap up. We have some final comment from George. I believe that it's could be translated as
Thank you for
further
joining.
in. Yeah, yeah. I think okay. Thank you, Sergey. At this positive notes, we can close the call, guys. Please put likes to Sergey, bells to the channel, and see you on our next stream. Sergey, thank you again for
Thank you,
this
thank you.
interesting talk. Bye
Hope
bye.
it was interesting and useful. Bye bye.